So I put 4 programs on your calculators. The first one is called derive. I don't have it on here, but you have it. It has all the derivatives listed. Okay. What you have to remember with each and every program that you use is there's a home screen that has the quit. So like number 7, you have to quit each program properly. If you ever forget to quit a program properly, so let's say I do Riemann, just as an example. So Riemann does the left hand, the right hand, the rectangular approximation method, right? Okay, and the trapezoidal rule. So let's say I just type something in, just as an example. I'll do x. So I'll do my, and then I don't know, 5 partitions. So see how I get this screen? It changes my viewing window. It changes everything, right? So do you see where it says quit? Well, if I quit out of here, like if you just press second quit or second mode, it's gonna mess up where it's gonna mess up my viewing window. Sometimes it'll change it to parametric equations and so on. Right. So to put it, if you ever get it out of, like you just wanna, if you go to second zoom, you just want to make sure everything, well, yours is probably going to look different. Everything on the left is highlighted.
The axis is on.
Yeah, and then like mode, you want to make sure everything is highlighted on the left because sometimes it'll go to parametric form. Yeah. So you just want to make sure that doesn't happen. And then you could always do zoom 6 to put it back in standard.
The drawing is not going away. You do second draw, third draw.
Right. Okay, so let's talk about each individual program here. So the Riemann sum you probably won't use too much, but it just allows you to do the left hand, right hand, midpoint, and trapezoidal approximation. So let's say I want to do, actually, let's do x squared. Let's do from 0 to 4, and let's just go with 4 partitions. The number of partitions means the number of subintervals or the number of rectangles, essentially. So that's saying I want to fit 4 rectangles.
You can find definite integral on this.
Right, you can also find the definite integral this way. So you can kind of compare which one's going to be the closest approximation. So it prompts you to press enter. So you have, the settings will go back and change anything you want. If you want to change your bounds, if you want to change the function. So if, let's say I want to do the left sum. And what it'll do is it'll draw in all the rectangles from the left, and it will give you your sum, which is 14 here. You press enter again, you can change that to the right sum by pressing 3, and it'll draw those 3 right. And then we could do the midpoint if we wanted. So if you had a problem on your, let's say the multiple choice, where you had your calculator, you could do these really quickly. Okay, you can also do the definite integral, number 6, and that will just shade, usually usually it shades it in. Here it is. So this is, if we were to do that by hand, we would get 21 1/3 essentially. Okay, you feel okay about that formula program? Okay, so let's go to the volume one, since that's really what we did next. Now, I get sometimes an error on mine, so I don't know if it'll work. Let's see. So just press enter. Okay, so volume it not only finds the volume, but it will also show you the area between 2 curves. Okay, so you're going to enter your curves. So let's use an example. First of all, we have f of x or f of y. So we can do where you have a top minus bottom or right minus left. So let's just do top minus bottom. Let's do...
When the axis of rotation is above, you always do the furthest away minus 3.
So your calculator will do it for you, which is kind of nice. So let's say I do square root of x, and then let's say my other one is, let's do e to the x. So you see how it uses the letter t? This is something called parametric equations, which we'll learn next year in BC. So it it's like it puts one function in terms of t and the other one. It's just the way that the calculator uses it. Now xmin, this is just my viewing window. Okay, it's not my bounds. So let's just go from 0 to 5, and then 0 to 5. Because if you think of e to the x and the square root of x, that's going to be only the, oh, how come that's going to go out? Oh, you know what? Hold on. Let me go back to number 1. Let's change this. Sorry, I'm going to go back to change this to square root of x. And then let's do e to the t. Let's do like minus 4. Sorry, I'm just, sorry. I'm going to just change this around a little bit. 0 to 6, and then let's go negative 5 to 5. I don't know if that'll capture it. Let's see what happens. There we go, that's better. I wanted to get like a region contained. I should have moved the e to the x to the bottom. Okay, so that's my region bounded by those two curves. So if we press enter, now if we enter the bounds, so press 3. So you have a choice. You can either enter them manually or you can find them graphically.
Yeah, if
So,
that was one of the ones I was having trouble with. If we don't know the bounds, do we have to do the intersects before this?
well, if you have a calculator available to you, you can do them either by typing one equation in y1 and the other equation in y2, or you can use this program. So what I'm going to watch, so for the lower bound, I'm going to use 0. So I'm going to just enter that manually, because technically they don't intersect on the left. So for this one, I'm going to put a 0. I think this is where my calculator gets a little funny. Now it's going to ask you for the upper bound. So I don't feel like wasting the time to try to figure that out manually. So I'm going to just do it on the graph. Okay, so we basically want, these are 2 graphs.
What are we supposed to do?
Press enter, no sign change. I wonder if I needed to move it over. Did you get an intersection?
I got that last time like that.
I don't think that it moves along the curve.
Did you move it over?
I'm moving over it.
Oh, apparently you have to move it
1.6.
over.
I should have moved it over before.
So it's 1.66.
There you go.
That's
So,
what I was doing wrong here the last time.
okay.
And that's when you cut the calculator.
That's when your calculator gets all crazy.
Took a while to get rid of this.
Well, if we go back. Okay, so you guys can keep going. So now the next thing it's going to ask you, you see how you have a choice of axis of rotation? So let's say you want to rotate it about y equals 0. Did you get that?
I got low up area. I got my area now.
It's telling me 1 moment.
Oh.
Got my area now.
And I got the area.
Okay, good.
Axis
So
of rotation. There we go.
Oh, 1 moment.
So this is going to be,
yeah, I'm just going to
Does
try
it
to
have saved the shaded in version already? Axis of rotation.
just trying to catch up to you guys here. So, all right.
You can't rotate around the x-axis.
So you said,
made it over to
what did you find for the upper bound? What was it? 1 point.
1.666.
Okay.
That's the horizontal.
So now it's going to shade it in. Okay, so, right, so we have a choice as to where we want to rotate this. We could rotate this, you want to rotate it about y equals 2. So then, if you're having to do this by hand, you're thinking about your big R minus your big R squared minus little r squared. Your big R, so let's say I make my axis of rotation
Horizontal or vertical?
horizontal. So in the middle here, it's going to give you your area. So let's say number 4, we'll go with Ben's choice of the y equals 2. So what it's going to do, it's going to draw y equals 2, and it's going to duplicate the graph, kind of make it symmetrical. Now, you can make these rectangles to try to get like a three-dimensional view.
Yeah,
Um, So that's kind of extra. You don't really need it. So if it gave you an option to clear a draw, but like basically if you press enter, oh, this is where my my program gets a little weird. Yours hopefully kept the actual drawing there still.
Where do I try it?
Just press enter and then press enter
Your
again.
draw means I say no, right?
Whoa.
Clear draw will just like in between each one, it'll erase like any preceding rectangles you had. And then here it'll give you your volume.
Just draw a rectangle.
Yeah, you can draw multiple rectangles. It'll give you the option to clear your drawing. If you want to keep the other rectangles still there,
Where is the volume?
so go back to the home screen where you have all your choices. You see where it says answer?
Yeah.
Click answer.
So cool.
Yep, there we go.
61.777, about the line y equals 2. So it kind of verifies what you did.
Yeah.
And then just make sure you go back to the home screen. You press 7 for quit. So then hopefully, like if you go to your mode, everything went back to normal. It's no longer in parametric. Hopefully your window, if your window gets weird, just go back to put it in standard if you want. Okay, the other formula is a slope field. So slope field deals with differential equations. Differential equations are the types of problems where you move the dx to the right side, right? You separate variables if you need to, and then you take the integral of both sides, right? And then you end up with a plus c, then you plug in your initial value, and then you figure out what c is equal to, and then plug it back in and solve for y. So the whole idea is you can input a differential equation. So let's input dy dx. So let's say it's x over y.
It's case sensitive to y.
It will graph in terms. So you could do x and y. So let's say
Is there like
alpha, go
y?
alpha, and then the number 1
Okay,
is
so it was that one.
yeah. Okay, so what we can do is just x over y, we can view the slope field. So let's view the slope field first, number 4. So this will graph your slope field. So remember what it does. It creates little line segments that represent the slopes at particular points. Okay. Now, if you have a particular solution, so this is a way where the known solution, what this will do is this should verify that we solved it correctly. So if you have x over y, do you know what this would end up being?
Yeah.
What kind of shape?
With the
Think about it. Here, let me explain.
Square root of x over 2.
Think about it for a minute. So if I have dy dx equals x over y, what would you do? You want to separate the variables. So it would be y dy equals x dx, and then we would integrate. So it would be, y squared over 2 equals x squared over 2 plus c.
Yeah.
So this is really, right, so basically what we have, I'm giving you an example. Y squared minus x squared is a hyperbola that goes like up and down or sideways. So let's just say that we have a solution, let's say y of 0 equals 2. Okay? So in that case, we would have 2 squared over 2 equals 0 squared over 2 plus c. right? So we'd have 2 equals C. So then we go back to here. So y squared over 2 equals x squared over 2 plus, oops, that's supposed to be 2. So now we want to isolate y. So we multiply everything by 2. We get this. And then we square root everything. Now technically we would get plus or minus. Right, we need to make sure the initial condition holds true, so it's got to be plus. So now, let's say you had this on a free response question that was calculator okay. You could go to number 2.
Still write down the stuff? Like, some steps? Or
Yes, so, yeah, there will be some places where you need to show some work. Not every step.
Known solution?
Known solution. So I'm going to type this in. And then, oh, you can also change your window, by the way.
Now I do view to view.
Yeah, now watch what happens when I graph it. Take a look at what it does in my slope field.
No, we tried doing that.
So now,
Do after you do
oh, I'm sorry. So after you typed in the known solution, go back to view your slope field. So what's neat about this is if you get something that's completely wrong, you'll see that it doesn't follow your slope field. But I did. It follows really nicely the slope field. So, and it goes through the point 0.02, which was what we wanted. So we know we got a good solution here.
Let me just write down, so I don't forget what known solution is.
Okay. And so like number 3, you can change your window. You can zoom in, zoom out, you know, you could change the resolution if you want, and so on. You could, right here. So you can just change things around if you want. Okay? So that's how those 3 programs work. Okay. All right, I'm